Alright, welcome back. So in our last video we went over the definitions for some of our vocab terms. Remember, it's another example where if you look something up on Google, you're going to find other answers and they're not necessarily the right answers. So make sure you're trying to stick with the meaning of the vocab words that we have here that you get from the book. Science-related definitions to these vocab terms. Okay, down here under I can, so I can identify the appropriate electron dot diagram for each element. So if you go back into the book, each dot on the electron dot diagram represents a valence electron. So if I have something like hydrogen with one valence electron, I'm going to put one dot next to it. If I go down further to something like nickel, element number 28, it has two valence electrons, so it would have two dots next to it. Some of the other ones like krypton, element number 36 has 8, so it would have 8 dots around it. Just make sure you understand where those dots, where the number of dots comes from, the valence electrons, and how to place those dots. Okay, so here on this screen, I'm going to help you go over how to make, or how some of those electron dot diagrams should look. Now on the test, I'm not going to make you draw any of the electron dot diagrams. That would be a real pain to do in Schoology. But I will have you identify it from a list of multiple choice options. So if I have an element like hydrogen, element number 1 has one valence electron, it's going to get one dot. Okay, and as I said, if you look further down, I use element nickel. So nickel, element number 28, capital N, lowercase I, and it has two valence electrons. So there's a couple different ways you could put this. You could do one here and one up here. You could do two on the sides right here. You could do one on this side and one on this side. Those are all fine. The general idea is that around each element there are these boxes that each can fit two valence electrons. So as long as you don't have more than two per side, and as long as they aren't sticking out past those boxes, then you should be fine. A different color here, do yellow. So here are some unacceptable options. Here's nickel, and I'm putting two dots there. No. Here's nickel, and putting two dots like up here. No. Let's do another example, something with a few more valence electrons. Let's do chlorine. Okay, chlorine has 7. So I'm going to do 1, 2, 3, 4, 5, 6, 7. Now you'll notice over here I have one empty spot. That's what I'm looking for because I only have 7 valence electrons. Those are all acceptable answers. Here are some wrong answers. Chlorine, 1, 2, 3, 4, 5, 6, 7. That's wrong. Chlorine, 1, 2, 3, 4, 5, 6, 7. Something like that. It's wrong. Okay, so make sure you're following the system that we have here. These little boxes around your element can fit no more than 2 valence electrons for a total of 8 valence electrons. Once I have more than 8, they're going to jump out to the next energy level, and we're going to start over again, and we'll have 1 valence electron. Okay, so next on our list, we'll work our way down here, identify the differences between ionic and covalent bonding. So I'll put that down here in the notes. So differences between ionic and covalent. Ionic, it's a metal and non-metal. It's a cation and anion. It forms a compound. They transfer the electrons instead of sharing. They transfer the electrons. For covalent, it is a non-metal and non-metal. So the first thing you always want to do when you're giving a question, you got to decide whether it's ionic or covalent, is look at the elements. Does one come from the metals part of the periodic table and one from the nonmetals, or are they both in that nonmetals section? That'll tell you whether it's ionic and covalent. It'll tell you how to do the naming. It'll tell you whether the numbers matter for the prefixes. So these would transfer. So not transfer. These would share pairs of electrons, and they form molecules. Okay, next, identify the reactants and products of different chemical reactions. All right, so we'll flip back to our other screen here, and I will draw out a couple chemical reactions. We'll talk about the reactions and the products. All right, so one of our examples from last week, we had RbBr as a compound plus K. Okay, that had a chemical reaction, and we end up with KBr plus some unknown substance. So here's some things to know from this. Okay, these compounds and elements here, these are our reactants. These over here will be our products. These are the things that we made out of our chemical reactions. Okay, so if I look at all of my elements, Rb, if I look on my periodic table and I scan through, there we go. In group 1, period 5, Rb, element number 37, rubidium. Rubidium is a metal. Okay, then I look around some more and I try to find Br. So I scroll through. There we go. In group 17, period 4, there's bromine. And this is a non-metal. And then I look here, looking for K. K is in group 1, period 4, element number 19, K for potassium, because, you know, that makes sense. And if you actually went back and looked at where the word came from, potassium used to be called kalium. Okay, kalium's with a K. And if I look on my periodic table, I have this, it's over on the left side, so that means it is metal. So I have a metal and non-metal compound, so an ionic compound, and a metal. And I look over here, I have a metal and a non-metal, forming another ionic compound, plus what? What is missing? Well, my K is right here. My bromine is right here. So what I'm missing is the rubidium. So my missing piece of the puzzle, my missing product, is Rb. So on the test, if you got the blank, what am I looking for? The symbol Rb. Now, just for a little bit more practice, let's talk about how to name this compound. So RbBr, that's a compound of metal and a non-metal. It is ionic, which means I don't use the prefixes, which means I don't have to worry about the numbers. I leave the first element as it is, so I have rubidium, and then bromine becomes bromide. So rubidium bromide plus potassium gives me potassium is a metal, bromine is a non-metal, so I have another ionic compound here. So ionic, I don't have to worry about the numbers for the naming because I don't use the prefixes. I leave the first element, potassium, and Br again is bromide, plus draw this down here so I have a little bit more room. Rubidium. So rubidium bromide plus potassium gives me potassium bromide plus rubidium. So last question, what type of reaction would this be? Well, if I go through my list, the first vocab option was decomposition, chemical reaction in which a compound breaks down into two or more simpler substances. Do I have a chemical compound breaking down into two or more substances? No. If I had RBBr giving me RB plus Br, that would be decomposition. So, not decomposition. Next, we have single replacement, a chemical reaction in which one element takes the place of another in a compound. So we have potassium, and our potassium is taking the place of our rubidium in our compound. Okay, see how those two, they switch places. So this is a single replacement reaction. Alright, so that's I can statement number 2. Let's look at number 3. I can identify the reactants and products of different... Oh, no, that was number 3. So now we're on number 4. I can determine the ionic charge of each element. So determining the ionic charge of each element. I don't think we'll have time for that one in this video. Next, you can write the symbol and name form of ionic and covalent bonds. So we just did some ionic ones. We'll take a look at some covalent ones. And then I can determine the type of chemical reaction based on the reactants and products. So we just did an example of that. So these last two determine the ionic charge of each element. And then write the symbol and name form of ionic and covalent bonds. I'll throw together one more video for you guys covering those things. And then I'll look to see if you guys have any questions. And I'll go from there.